Welcome to clickmyproject.com. Let's discuss the project about tree metric graph cuts for brain MRI segmentation with tree cutting. We present a novel approach to apply graph cuts algorithm with tree metrics using pruning to the medical image segmentation problem and compare our result with the state-of-art methods. Our approach, which is efficient in computing and globally optimized in the tree metrics labeling, performs better than the conventional approaches in terms of the overall accuracy and avoids the iterative method, which is computationally intense. The approach has three steps. First step is pre-processing, which generates a tree of labels as input to the TM algorithm, and then second step is a sweep of the TM algorithm, which returns a globally optimal labeling with respect to the tree of labels, and the third step, post-processing, which involves running the tree cutting methods to generate a mapping from labels to tissue classes, producing a meaningful brain MRI segmentation. The TM algorithm produces a globally optimal labeling on tree metrics in one sweep, unlike conventional methods such as EMS and EM style geocuts, which iterate the expectation maximization algorithm to find hidden patterns and produce only locally optimal labels. When used with the tree cutting method, the TM algorithm produces brain MRI segmentations that are as good as the unified segmentation algorithm used by SBM8 using a much weaker prior. This is our flow of our process. First we load our input brain images, then we will go for pre-processing step. In the pre-processing step, we are removing noises in our input images. Noise is nothing but any undecided information that contaminates on image. These noises are removed using some types of filters. Here we are using median filter to remove the noises. Then we will go for a tree metric step. To apply the tree metric graph cut algorithm to brain MRI segmentation, we perform pre-processing to create suitable inputs to the TM algorithm and post-processing on the output segmented written by the TM algorithm to create a meaningful brain segmentation, classification the tissue at each voxel. The TM algorithm takes three things as input: a brain MRI image, a tree of labels, and a smoothness parameters lambda greater than or equal to 0. We generate a tree of labels with agglomerative clustering based on observed gray level intensity. We apply the TM algorithm to the brain MRI image and the tree of labels, which returns a globally optimal labeling of the brain MRI with respect of the tree of labels. Three stages of our TMTC algorithm are tree generation, sweep and pruning. Our first step is tree generation. We use agglomerative hierarchical clustering to create a tree of labels. In agglomerative hierarchical clustering, closest pairs of clusters in the feature space are repeatedly merged such that the distance between two clusters C and D reflects the increase in variance of the feature vectors in C union D relative to the variance in C and D. Next, we will go for tree metric algorithm sweep. We have generated a tree of labels represents the tree metric distance function D. We apply the TM algorithm to the brain MRI image, the tree of labels, and the smoothness parameter lambda greater than or equal to 0. And then we will go for tree cutting. The labeling returned by TM algorithm does not directly correspond to the tissue classes in the brain. Therefore, we need to map the grayscale labels to 4 labels: gray matter, white matter, CSF, and also background. Finally, we will go for our performance evaluation. In that, we are counting the pixels, gray matter, white matter, and we will also find the PSNR and MSE values and also entropy value. Now let us see the execution of the process. First we select main.m file and click run file. This is a MATLAB guide window designed for tree metrics graph cuts for brain MRI segmentation with tree cutting. First we load our input image. These are the input images available in our data set. We can select any one of the images. Now I select this image, and then we will go for a pre-processing step. In the pre-processing step, noise are removal with the help of median filtering. Noise is nothing but any undecided information that contaminates an image. Here we are applying median filter to remove the noises. And then we will go for extracting the region of image. That is, if any unwanted things is applied in background means that thing is removed here, and original brain image region is extracted from this, and then we will go for our proposed tree cutting algorithm. It will take some time. The tree metric has 3 steps. First, tree is generated, and then sweep, and then pruning is done. First, in the tree generation, we use agglometric hierarchical clustering to create a tree of labels. In agglometric hierarchical clustering, closest pairs of clusters in the feature space are repeatedly merged, such that the distance between two clusters C and D reflects the increase in variance of the feature vectors in C and D relative to the variance in C and D. And then sweep is done, and then we will go for tree cutting. The labeling returned by tree metric algorithm does not directly correspond to the tissue classes in the brain. Therefore, we need to map the grayscale labels to 4 labels: gray matter, white matter, CSF, on also the background. We create this mapping with the tree cutting method. To reduce T56 labels to 4 labels, we cut our binary tree of labels at depth log 2 of 4 equal to 2. For each node at depth 2, their child subtree is now mapped to the same labels. This is our result of our proposed work. This is a gray matter, and this is a gray matter, and this is a white matter, and the outline is of our CSF. This is a result of our tree cutting algorithm. Then we will go for a calculation step. In the calculation, there are how many gray pixels that are counted and displayed here, and white matter pixels are counted and displayed, and CSF pixels are counted and displayed, and entropy, PSNR and MSE values are also calculated and displayed here. Then our algorithm works properly. Thank you.